company I work for just got a laser cutting system, and it's just too cool not to show in a video. This is an Epilogue Laser Mini. It's a CO2 laser. There's also a terbium fiber lasers. They're good for marking stainless. Certain materials with certain wavelengths convert the light to heat, and that's how it marks. A terbium fiber one is around 1062 nanometers wavelength. CO2 is a 10.6 micron beam. This one is a CO2, so it actually cuts. They're all around maybe 15 to 50 watts. This one happens to be a 40 watt one. I'll go ahead and show you. First it focuses, and if there's any raster images, like there's rasters on this, it'll go ahead and do the rasters first, and then it'll actually do vectors, and that's what it uses for cutting. There's a stainless steel plate you can put in here also for engraving big stuff or heavy stuff. The laser can hit the stainless steel, and because of its makeup, it won't convert it into heat, so the beam could shine directly on stainless, no problem, all day long. It will, however, reflect back. That's why we're using this honeycomb-looking plate, so the beam doesn't reflect back onto the part and melt it. So right now, this is the raster. The beam thickness for a CO2 laser is about 5 thousandths. So when you're making your parts, go ahead and account for about 2.5 thousandths on either side of the line you're cutting, because that's about the blast width. The CO2 laser is actually putting out a light you can't see, and then certain materials convert that into heat. Works really well in acrylic, doesn't like Lexan for some reason, no polycarbonate. You can vary speed, power, and frequency, and I'm not really sure how frequency works. It probably has to do with starting the laser and ionizing the gas. I'm not really sure. The terbium fiber is a very small beam. It's about 3.4 thousandths. But like I say, it's just made for marking. You can also mark on stainless with this, but you have to use a certain ceramic tape that actually fuses to the steel. It does pretty well on chrome and nickel too. I did I put my name on some parts and some tools. Right now it's 600 dpi for the rasters. It can go to 1200 dpi. Its repeatability is about 5 thousandths of an inch. And I'm using 50% power and 100% speed to mark the acrylic. It focuses when it starts up, or you can manually focus by raising or lowering the bed. You can't really focus on the fly. I mean, you can manually do it, but you can't make it do it automatically for, say, a bumpy part. What is neat, though, is this attachment here. It actually becomes the y-axis. So if you have, say, a flashlight that you wanted to engrave, what you do is you calculate the circumference of the flashlight, and it will roll the flashlight in that device as it would just index the y-axis, which is a pretty neat feature. There's a beam splitter in there. You can actually, now you'll see it cutting, and this is now a vector. It knows when there's a vector. It's just like a print driver. It knows it's a vector if it's 1/1000th of an inch thick. If it's 5 thousandths of an inch thick, then it actually interpolates it as a raster. it is optimized, so if you're just printing a little bit, it just moves. It doesn't move the whole size of your plate in raster mode. It's pretty smart. The flashes you see are other materials converting the invisible light into heat that had been cut before. I think we were cutting some Kevlar. But there you go, there's a finished piece. Hope you enjoy.